Right, so in this question, right, they say that the graph of f is shifted 2 units to the left to form p, right? Now, p is a new function. It's basically the translated function, right? We need to write the equation of the new function p of x, right? Now, if you can remember, the graph of g was this, or the graph of f, sorry, was this function over here, right? So remember, in the first question, they asked us to change the standard form into vertex form, right? Now you're going to see the benefit of the vertex form again, right? Let's just rewrite it. Okay, so we have, or we had, f of x is equals to 2 into the bracket x minus 1 all squared minus 8. Okay, now if you look at this f of x, right, you basically know that from the mother function just x squared, right, this has been shifted, right, 1 unit to the right. Okay, and why do we say to the right? Because this value here inside of the bracket, right, is negative, right? We have this negative 1 inside of the bracket, so that tells us that our original function, right, mother function, has been shifted 1 unit to the right. Okay, so now we need to take this function of f, right, and we need to shift it 2 units to the left. Okay, now remember that that shift of 2 units to the left is a horizontal shift, so it's going to be represented inside of the bracket, right? And if it's shifted to the left, then inside of the bracket that would be represented as a positive 2, right? So then we can just write the equation of p of x, right, is equals to 2 into x minus 1, right, plus 2. Right, now this plus 2 represents that shift to the left. Okay, right, and we need to square that. We still have that minus 8. Okay, now we can simplify this. So p of x is equals to 2 into x, right, minus 1 plus 2 is just a plus 1. Okay, and that's squared minus 8. Right, so that's the equation of p of x, right? But what does that look like if you want to visualize this quickly? Okay, if we visualize this, okay, our original function f, right, has an a value greater than 0, so it's facing upwards. Okay, because its turning point, right, was originally at a point 1. Okay, so 1 minus 8. Okay, and remember we said that its y-intercept would be at minus 6. Okay, so we can quickly just, if that's minus 8, that's roughly minus 6. Right, so just very quickly you would have some x-intercept and some x-intercept over there. Okay, that's not such a nice sketch. This is why I hate working in pen. Okay, no, let's resketch it because now it's bothering me. Okay. That's my x-intercept. Sorry, my x-axis. That's my y-axis. Right. Then it would look something like this. Okay. So this is the graph of f. Right. We're not going to be concerned about the x-intercepts now, but we know that from the shape it will have x-intercepts. Right, and this point is a point minus 6, and this point is at a y value of, so it's at an x value of 1, but it's at a y value of minus 8. okay, that turning point, right? Now when you take this graph and you shift it 2 units to the left, okay, it means that from this 1 you go back to 0, okay, and then you're going to go to a value of -1. Okay, so let's try to approximate this distance. Okay, -1. Right, so that's 2 units, right? 1, 2. Okay, so this is now the new position of your new turning point. Okay, now you see that the y value stays exactly the same at -8, because the only thing you've done is you've taken this graph of f and you've moved it horizontally. Okay, now I'm going to sketch it as well, but knowing myself, I'm now very concerned about where it's supposed to cut the x-axis, but let that not matter now. Okay, let it not matter. But basically all the values would shift to the left, okay? And maybe I wasn't supposed to put an axis because that's what causing me to be so finicky now, right? But I can, right, let me think about this point. This 0 minus 6. If it shifts 2 units to the left, it goes from 0, right? And then it goes to -1 and then -2. Okay, so it will go from an x value of 0, -1, -2. The y value would stay the same. So that's a point somewhere there maybe. Let me see. That value is 1 unit away from the turning point. Okay, so 1 unit away from our turning point, our new turning point of -1 is back to 0. Okay, so I'm going to yes. Ha! You see what being a perfectionist does to you guys. Doesn't just, it's not good. Right, so basically they are going to intersect. Right, I was worried about that. Now it looks like I made this graph much bigger than what it's supposed to be. That's why we call it a sketch. Right, so basically this is P. If I make this video any longer than what it's supposed to be, that's an x value of -2. Okay, so that's the transformed y-intercept basically. Okay. Okay, so the graph won't expand like what my sketch is trying to imply. The only thing that happens is that the x values shift. Right, now let's see, let's compare the equations. Right, so the equation of f of x was 2 into x minus 1 squared minus 8, right? And that gave us a turning point at 1 minus 8. Okay, you can see it there, right? And we just determined the equation of p to be 2 into x plus 1 squared minus 8, right? And that gives us a turning point at -1. Remember, it's the opposite of what you see inside the brackets, -8. Okay, so you can see that you just went from a value, an x value of 1 to an x value of -1, and that's a difference of 2 units. Okay, this is a difference of 2 units. Okay, so there you go. You see the graph of f is shifted 2 units to the left. Right.